A maintenance technician is about to repair a conveyor system. The machine appears to be switched off and the team is ready to begin. But without warning, another worker presses the start button. The conveyor suddenly starts moving. Unfortunately, no one is injured, but this near miss could easily have become a fatal accident. Incident like this happens when hazardous energy is not properly isolated. This is exactly why Lockout Tagout or LOTO is one of the most important safety systems in any industrial workplace. In this video, you will learn what Lockout Tagout is, why it is essential, and different types of hazardous energy, the complete Lockout Tagout procedure, common mistakes, and practical example from industrial workplaces. Lockout Tagout is a safety procedure used to isolate hazardous energy before maintenance, inspection, cleaning, or repair works begin. Its purpose is to prevent the unexpected start of the equipment or the sudden release of stored energy that could seriously injure or kill workers. Turning a machine off is not enough. Electrical, hydraulic, pneumatic, mechanical, gravity, thermal, and stored energy can still remain inside the equipment. Unless these energy sources are properly isolated and verified, the equipment may move unexpectedly, causing crushing injuries, amputation, electric shocks, burns, or even fatalities. Before we learn how to perform Lockout Tagout, we first need to understand the different types of hazardous energy that may be present in industrial equipment. When people hear the word Lockout Tagout, they often think only about electricity. However, hazardous energy exists in many different forms. Any source of energy capable of causing injury must be identified, isolated, and controlled before the maintenance work begins. Electrical energy powers motors, conveyors, pumps, and production equipment. Simply switching equipment off does not always isolate the electrical supply. The energy source must be disconnected, locked, tagged, and verified before work begins. Hydraulic and pneumatic systems store energy under pressure. Even after the power has been switched off, pressurized liquid or compressed air can still move cylinders, valves, or mechanical parts. Before maintenance begins, the stored pressure must be safely released. Moving parts and suspended loads also contain hazardous energy. For example, rotating shafts, conveyors, rollers, flywheels, springs, and elevated equipment can continue moving or fall unexpectedly if they are not properly secured. These hazards must be controlled before anyone enters the danger area. Some equipment remain dangerous even after it has been isolated. For example, hot surfaces, steam lines, heated process equipment, charged capacitors, compressed springs, and rotating flywheels may still contain stored energy. Before work begins, all stored energy must be safely dissipated or restrained. Now that we have identified the different types of hazardous energy, the next step is learning the complete LOTO procedure, from shutting equipment down to verifying that every energy source has been safely isolated before work begins. Every Lockout Tagout procedure begins with proper planning. Before touching the equipment, identify all hazardous energy sources, understand how the machine operates, review the manufacturer's instructions if required, and inform all affected employees that the equipment will be shut down for maintenance. Once everyone has been informed, the equipment is shut down using its normal operating controls. This ensures that the machine comes to a control stop before any energy-isolated devices are operated. The next step is to isolate the hazardous energy source. Depending on the equipment, this may include electrical disconnect switches, hydraulic valves, pneumatic isolation valves, steam supplies, or other energy source. Every source which is capable of energizing the equipment must be isolated. After the energy source have been isolated, Each authorized worker applies their personal lock and warning tag. That lock physically prevents the isolation device from being operated, while the tag clearly identifies who applied the lock and why the equipment must not be started. Isolating the energy source is not enough. Any stored or residual energy must also be released or safely restrained. Hydraulic pressure should be relieved, compressed air vented, springs secured, suspended load supported, and capacitors discharged before work begins. Before anyone starts maintenance, the isolation must be verified. Attempt to stop the equipment using the normal controls. Machine must not operate. So, this verification confirms that every hazardous energy source has been successfully isolated and that the equipment is in a true zero energy state. The equipment has now been properly isolated, locked, tagged, and verified. Maintenance can begin safely. However, even a well-designed lockout tagout system can fail if the basic rules are ignored. So, let's look at some of the most common mistakes. One of the most dangerous mistakes is believing that pressing the stop button or switching the machine off is enough. The stop button only stops the equipment. It does not isolate the hazardous energy unless the energy source has been properly locked out and verified. The equipment can still restart unexpectedly. Every authorized worker must apply their own personal lock. Never rely on others' personal lock to protect your life. Your lock should remain in place until your work is complete and you are safely cleared to the equipment. Applying locks and tags is not the final step. Always verify that the equipment cannot start and that all hazardous energy has been removed. Verification is what confirms the machine is truly safe to work on. Another serious violation is removing another worker's lock without authorization. A personal lock must only be removed by the person who applied it unless the organization has a formal emergency removal procedures, which is carried out by authorized management in accordance with the company policy. Now, let's review the complete lockout tagout procedure one final time. Prepare for the shutdown. Shut the equipment down using normal controls. Isolate every hazardous energy source. Apply personal locks and warning tags. Release any stored energy. Verify the zero energy state. Only then maintenance begin. Work is complete. Inspect the equipment. Remove tools. Ensure everyone is clear. Remove personal lock according to the procedure and safely return the equipment to the service. Remember these key principles every time you perform maintenance. Never assume equipment is safe because it has been switched off. Always isolate every hazardous energy source. Use your own personal lock. Verify zero energy state before touching the equipment. And never remove another personal lock unless the approved emergency removal procedure has been followed. Lockout tagout is more than a safety procedure. It is a life-saving system that protects workers from unexpected release of hazardous energy. By following the correct sequence every time, we can prevent serious injuries, equipment damage, and fatal accidents. Thank you very much for watching Safety with Zahid. If you found this video helpful, please like, subscribe, and share it with your colleagues. Stay safe, work smart, and always verify zero energy before starting the maintenance.